Orange giants. In our main sequence star, it generates energy from hydrogen fusion in the core. But that uses up the hydrogen over time, and it replaces it with helium. So eventually, the core is going to have 0 hydrogen and only helium. And so we call that an inert helium core because you can't have fusion at this point. It's not hot enough for other forms of fusion, and we've run out of fuel. Our hydrogen has run out. So we have a core composed entirely of helium, but there's no energy production now. So without energy production, there's nothing pushing out to support the star. Because up to this point, all the energy production in the core has balanced gravity pulling in. Well, now we just have gravity pulling in and nothing pushing out. So our star is going to collapse. So we're going to see this stage of the star getting smaller. But it doesn't last very long. Because when you collapse a gas, it's going to get hotter. And so that's what's going to happen in the interior of our star. This internal region is going to get very hot. And eventually, it's going to get hot enough that this little ring, I'm trying to decide a color here, I'm going to use green, just outside the core is going to get hot enough for hydrogen fusion. And we call that ring a shell. So this is shell burning. So hydrogen shell burning is what we've got happening here. So that is now going to start producing energy. And so that energy will push out. So that's going to cause the entire star to expand and get bigger. And here we see a graphic comparing a star at this stage to the size of our sun. In our case of our sun, this will extend to about the orbit of Venus. Now the other thing that happens when a gas expands, it cools. So the outer part of this star is going to be very cool. Very center of the star is going to be very hot. So you're going to have a very stark temperature difference between what's happening in the very center of the star versus what's happening on the surface of the star. So this cool temperature is of the surface. The center is still going to be very, very hot. And of course that affects the color, which is why we say it is orange in color and why we call it an orange giant. So giant because it's big, orange because it's cool. And our main characteristics of an orange giant is that it has a helium core that is inert, That is, no energy is produced, it's just collapsing and getting hotter. And we have a hydrogen fusion shell. Those are the key characteristics of an orange giant. Now this stage doesn't last terribly long compared to the lifespan of a star. This plus the red giant stage is about 1% of the lifetime of a star. So they're relatively short periods of time. In the case of our sun, few 100 million years. Yes, that sounds like a long time. But in the lifetime of a star, that's actually relatively short. So orange giant stage, relatively short period of time in the life cycle of a star.